All right, so if you are new here, thank you so much for joining us today. And I'm also glad for those who are always here learning with me. So in this video, we are going to talk about exponential function. We are taking the first case, right? So we are looking at the idea that the non-homogeneous aspect is a, let me say, exponential function, right? So remember what we just learned. We said if this is not the same, guess this, and then we just need to learn this. So let's take example, and then I'll show you step by step how you are going to go through the process. So this is non-homogeneous second order. Why? Because this is equal to 3e to the power x, right? So this is how we need to go through the process. So since this is our first video, I'll take my time and break them down. Then when we are taking the other questions, I'll just go straight, right? So I have 4 questions here that we are going to go through together. Then I have a trial question at the end of the video for you to also try. Good. So let's start. So given this, what we need to do is first we need to consider the homogeneous aspect. But I'll just give some few notes here. Now we know that the general solution is given by y, which is equal to yc plus yp. Now the yc is the complementary solution, and then the yp is the what? The particular solution. So the first thing that we need to look for is we need to find the complementary solution. So this guy here is the complementary solution. Complementary solution. And then yp is the particular solution. Good. And you are going to understand it better. And I said, for us to find the complementary solution, we need to consider the homogeneous aspect. So we are going to start by saying for complementary solution. So as I said, I will be writing a lot in the first example because I want you to understand what we are doing before I'll be going straight forward to the solutions. So for complementary solution, then we need to consider the homogeneous aspect. So y prime prime plus 3y prime plus 2y should be equal to 0. So we ignore this and we set it to 0. And we know how to do this from the videos that we learned. Homogeneous aspect of the second order differential equation. So I'll be going through this very quick. So we said first assume that y is equal to e to the power mx, then y prime will be equal to me mx, and then y prime prime will be equal to m squared e mx. So we've been doing this, so remember them. So this is going to give us m squared e to the power mx plus 3m mx plus 2mx is equal to 0. So I was just doing substitution inside this homogeneous equation. So let's solve it quick. Factor this out. M squared plus 3m plus 2 is equal to 0. So I just factored this, and this out. Now we said that when we get here, we need to assume that this guy is never 0. And if that's the case, then the characteristics polynomial will be equal to m squared plus 3m plus 2. And then after we've gotten the characteristic polynomial, what we need to do is we need to find the characteristics equation, which is this equal to 0. And then we solve for the function, right? So as I said, here you can use factorization, or you can use, let me say, quadratic. And as I said, you can use the quadratic formula because you don't know whether this is going to be, let me say, a complex or is going to give us a distinct 2 root. So you can just look at the equation and then you can guess. So for me, I can see that this is not going to give us complex because when I square b and I multiply this one by 4, this one will be 8, this one will be 9. So there is no way it's going to be complex. So I can just do factorization from here. So I can factor this one as, or let me just use quadratic so that we can just move forward. So m will be equal to, let me say, minus b plus or minus square root of b squared minus 4ac divided by 2a. A is equal to 1, b is equal to 3, and c is equal to 2. So from this. Now m will be equal to minus 3 plus or minus square root of 9 squared minus 4 times 1 times 2, all divided by 2 times 1. So what are we going to get? Minus 3 plus or minus square root of 3 squared is 9 minus 8 divided by 2. So what are we going to get from here? Minus 3 plus or minus square root of 1 divided by 2. And this is going to give us minus 3 plus or minus 1 divided by 2. So m1 will be equal to minus 3 plus 1 divided by 2, which is minus 2 divided by 2, and this is minus 1. And then m2 will be equal to minus 3 minus 1 divided by 2. This is minus 4 divided by 2, which is minus 2. So we've gotten m1 and m2, and they are distinct. So we know how to write the complementary solution for this. When they are distinct, we assume that, so I'll write the complementary solution somewhere here. So when they are distinct, we are saying that the complementary solution, if it was the homogeneous, we are going to call it a general solution, but this is non-homogeneous. So we are going to call it a complementary solution. So the complementary solution will be equal to C1 e to the power m1x plus C2 e to the power m2x, right? So my complementary solution is going to give us C1, m1 is minus 1, so C1 e to the power minus x plus C2 e to the power minus 2x. So this is my complementary solution. Now, let me go and guide you through the particular solution, because that's basically what is new here, right? So I'll write the equation again, the differential equation again here. So y prime prime plus 3y prime plus 2y is equal to 3e to the power x. So this was the equation that was given to us. And then we've gotten a complementary solution. What is this? So let me just copy it and paste it there. So we've gotten the complementary solution, this. So for us to get our general solution, we need the particular solution, and then we are done, right? So we've gotten this, it's left with yp. So now this is an exponential function, and as we said, now we are going to take a guess, right? So we are going to guess a trial solution. So that's what we are going to do here. Now, anytime you want to guess, this is what I just want to show you. Look at the function here. This is e to the power x. Do you have some here? No. So you will see that here our y p is going to be a e to the power x. So as I said, anytime we want to give a trial solution, we pick what is here, then we multiply by a constant. That is whenever it is an exponential function. Look at what is here and multiply it by a constant. So I'm assuming that I have a and I multiply it by this. And when I'm done, you know that we have another solution that is going to be like ax this, and we have another one which goes with x squared this. We can also have something like this, that, right? But for me to choose this, or this, it depends on my complementary solution. So this is the first trial solution that I need to write anytime I'm dealing with exponential function. Now compare this to this and see if they are the same. Now remember, this is a constant, this is also a constant. But compare this. Is this the same as this? No. Is this the same as this? No. So it means that the trial solution is going to be this. So that's how we go through the process. Good. So now that we've gotten the trial solution, then this is like y, like what we just started from here. When we had y, what did we do? We differentiated it, and we plug it inside the homogeneous equation. But here we are going to differentiate it and plug it inside the non-homogeneous equation. So this is going to give us y prime, which is going to be, when I differentiate this, I get the same thing. Y prime prime again, this is going to give me the same thing. So I'm going to plug in this into the non-homogeneous equation or the original equation. So let's see what we are going to get. We are going to have AEX plus 3 AEX plus 2 AEX, which is equal to 3EX. Very simple, right? Then what we are going to do is we are going to group like terms, left and right? So basically we can see that these are all the same, right? We have EX, EX, EX. We have 1A, 3A, and then 2A. So when I add the whole of this, I'm going to have 6A e to the power x, which is equal to 3e to the power x. So compare. If I compare this and this, the coefficient of e to the power x here is 3. The coefficient of e to the power x here is 6a. So this is going to give me 6a is equal to 3. And then I divide through by 6, and I'm going to have 1 divided by 2 as my a. So now that I've gotten my a, then what will be my particular solution? Remember, this was the solution that we guessed. So it means that the particular solution is going to be a was 1 over 2. So I'm going to have 1 over 2 e to the power x. Now, we are calling this a particular solution because there is no a constant. Remember, this that we had here is kind of general solution. That's why we are calling it a complementary, because it depends on the constant, right? And this one has no constant. That's why we are calling it a particular solution. So now for me to get my general solution, I add this to this. Then I have my general solution. So you see that it's very simple, right? So general solution now is going to be y, which is equal to c1 e to the power minus x plus c2 e to the power minus 2x plus the particular solution. Particular solution is 1 over 2 e to the power x. And we see that this is a general solution because it's in terms of what? Constant. So here too, we can also look for another particular solution when they've given us initial condition by finding C1 and C2. Then we are just going to get the particular solution from the general solution again. So that is how we go through the process. Let's pick another form that brings us different, assumption. So now let's look at question 2, the same process. So as I said, this one was the first video, so I was writing a lot. So this one I'll be writing, skipping some of the steps, but I'll give you all the details too as well. So the first thing that we need to write here is to remember that general solution is equal to general solution. General solution is equal to the complementary solution plus the particular solution. So we are saying that for the complementary solution, which is for yc, then we need to have y prime prime minus 3y prime plus 2y to be equal to 0. So that is what we are going to get from this. Then if this is the case, then we go through the process. So y is equal to e to the power this. So when you solve more, you see that you will write this one without even knowing how it came, right? So we are basically differentiating it, and we are going to get this. Let's do substitution. We are going to have m squared mx minus 3 mx plus 2 emx is equal to 0, right? So basically we are making the math very fun from here. So I just substitute this inside this equation. So again, factor this out. So plus 2 is equal to 0. And then again, this shouldn't be equal to 0. And then m squared, our characteristics polynomial will be m squared minus 3m plus 2, right? And for us to get the characteristics root, we need to set this to 0. So again, I'm going to use the quadratic. So quadratic a is 1. That's the coefficient of m squared. B is equal to minus 3. That's the coefficient of m. And then c is the constant, which is 2. So the quadratic formula, I'll just write it straight. This is going to be minus 3 plus or minus oh, okay, good. So this should be minus 3 because the formula goes with minus b. So like this, minus b plus or minus square root of b squared minus 4ac divided by 2a. So we are just doing substitution from there. So plus or minus square root of minus 3 squared minus 4 times 1 times 2, all divided by 2 times 1. So this is going to give us 3 plus or minus square root of 9 minus 8 divided by 2. So let's do that. This is going to give us 3 plus or minus 1 divided by 2, and we are going to have something like this. So m1 will be 3 minus 1 divided by 2, which is 2 divided by 2, and this is 1. M2 is going to give us 3 plus 1 divided by 2, which is equal to 4 divided by 2, which is equal to 2. So now that we've gotten our M1 and M2, let's write out the complementary solution. So complementary solution is C1 e to the power. So we see that this is distinct, right? So we are going to have M1 x plus C2 M2x. So YC is going to give us C1 e to the power x plus C2 e to the power 2x. So this is the complementary solution. Let's go through and work out the homogeneous aspect. So we saw that the question is this, which is equal to 4e to the power x, right? And then the complementary solution that we had, we said this is equal to, let me see the complementary solution again. Okay, c1 e to the power x plus c2 e to the power 2x. Good. So as we know that the general solution is the complementary solution plus the particular solution, now we need to find a particular solution. So for yp, let's yp to be equal to aex. So I said always, it's not always ae to the power x, it's a times the function which is equal to here. So if this one is e to the power minus 2, this one will be ae to the power minus 2x here. So that is how we are going to do it. Now, after you've guessed this, remember that we have other solutions there. This, we have this in that order. So for you to continue doing the thing, what you need to do is compare this to the complementary solution to find out if they are not the same. So this is a constant, this is a constant. We have e to the power x, which is the same as the e to the power x here. So it means that this is the same as this. Because remember, this is a constant, this can be 2, this one too can be 2, and this will be the same as this. So we cannot have a particular solution which is repeating itself in the complementary solution. So we need to modify this so that it will be different from this. So what can you do here? We need to move to the next solution by multiplying through by what? X. So it means that this is not going to work for us when we are solving it. So we need to now move to x e to the power x like this. So that is basically what you need to know. So always start by stating a constant times your exponential function here, and then compare the exponential function here to your complementary solution. So we saw that we have e to the power x here, and we have a constant. It means that we need to modify this by multiplying by x. So that's basically what we've done here. And when you multiply by x, you need to check it again. So now, when you look at this, we see that, okay, this is e to the power, which is also here. This is different. This is 2, so we don't compare. We have a constant, but this is x, which is differentiating this from this. So now it means that we can take this as the trial solution. So now that you are done with the trial solution, The rest is the same thing, the same process. Differentiate and do substitution here and just find for the constant a. That's all. So basically that is the most important thing, is to know how to get your trial solution, and the rest is just the normal calculation. So let's go. Yp prime will be equal to, here we need to use the dot product. So I have a. When I want to use the dot product, first I'll maintain x and differentiate this, which is going to give us the same thing, plus I'll maintain this and differentiate x, I'll get 1. So I'm going to have something like this. Good. So as I said, I have video coming up on derivatives, which breaks down everything that you need. So no matter the level you are in, whether the first year, second year, third year, or fourth year, you can check it out, and then you'll be able to master derivatives so that you'll be good with this. So I will drop out the link in the comment section so that you can just use it to watch them. Good. Let's find y prime prime. Y prime prime, still I have my constant here. I need to differentiate this using the product root again. So I'll maintain x and differentiate this. This is going to give me the same thing, plus now I'll maintain this one and differentiate x, which is going to give us this, plus now I need to now come and differentiate this, and then I have the same thing. So I think I can simplify this as okay, I can also simplify this and have ax e to the power x plus a e to the power x, right? And this one is going to be this x plus 2e to the power x, and this is the same as ax e to the power x plus 2a e to the power x. So what I'm going to do is I'm going to plug the second order, the first order, and then the y inside my original differential equation. So let's do that. Y prime, so y prime is this, so I'll write it down here. So I'm going to have a x e to the power x plus 2a e to the power x minus 3 times y prime, which is ax e to the power x plus a e to the power x, and then plus y plus 2y, right? So y is ax e to the power x, which is equal to 4 e to the power x. So now let me try and simplify it, and I'm going to have ax e to the power x plus minus 3ax e to the power x minus 3a e to the power x plus 2ax e to the power x, which is equal to 4 e to the power x. So can we group some like terms? This and this and this are the same. Can you see that? I mean, this and this and this are the same, and it will be 0, right? Because this plus this will be 3 minus this will be 0, right? And then this and this, oops, how is everything going to 0? Okay, let me check it out again. Okay, this one is 2 because all of them cannot go to 0. Good. So from here, this is 2. So this and this and this will be 0. And then this minus this is going to give us minus a e to the power x, which will be equal to 4 e to the power x. So now what will be our a? What should be our a? So the coefficient of this one, the coefficient of this one. So the coefficient of this one is 4, the coefficient of this one is minus a. So this one will be minus a is equal to 4, and a will be equal to minus 4. So that is what we are going to get from here. So now that we've gotten a to be minus 4, it means that our particular solution will be minus 4 x e to the power x. And then now we add the particular solution to the complementary solution to get our general solution. So the general solution is going to give us y, which is equal to c1 e to the power x plus c2 e to the power 2x minus 4 e to the minus 4x e to the power x. So you see that now this is different from this. If not that, if you try using the first term, it is not going to work out. Everything will get to 0. Good. I should have even used that one to try, but it's okay. Let's go to another one. So as I said, we are going to different questions. So you saw the first question, how we got it, the second question to how we got it. Let's look at this one too and see how we are going to write out the guess, right? So that is basically what is important here. We are looking at how to write the guess. So the same thing again, general solution is y equals yc plus yp. So for yc, we need to consider y prime prime minus 4y prime plus 4y to be equal to 0. So let's do the same thing again. So we know this already, which is nice. And then y prime prime is equal to m squared e to the power mx. So let's do substitution. M squared e to the power mx minus 4 m e to the power mx plus 4 e to the power mx is equal to 0. So let's solve that. Factor this one out. M squared minus 4m plus 4 is equal to 0. Then we make sure that this is not 0. And then m squared minus 4m plus 4 is our polynomial function. And for us to get the characteristics root, we said this minus this plus this should be equal to 0. Right. So as I said, you can use the quadratic or you can just use this one to solve. So this one, I'm not going to use quadratic. I can just do the factorization. So I want to do the factor. So 2 minus 2 minus 2 minus 2 is minus 4. And 2 minus 2 times minus 2 is 4. So this one works. So I'll combine this and I'll combine that. So when I factor m out, this one will be left with m minus 2. And when I factor minus 2 with the one with the blue, it will be left with m minus 2, which is equal to 0. So m will be equal to 0, which is m is equal to minus 2. Another this, which is equal to 0, and m will be equal to minus 2. Okay, no, it should be 2. Good. So now we can see that the homogeneous aspect is giving us a repeated root. So remember how to write the solution. So our complementary solution will be c1 e to the power mx, because they are the same, plus c2x. So remember, we need to multiply this one by x, e to the power mx again. So let's do that. Our complementary solution will be c1 e to the power 2x plus c2 e to the power 2x. So this is the complementary solution, and we need to look at the particular solution. I made a mistake here in my question. This guy here should be 2. So let me change that one. This should be 4 e to the power 2x. So that's what I wanted to use so that I can show you one of the things that you need to know. Good. So now that you've gotten the complementary solution, the next thing to do is to work with the particular solution. So the same thing, let's go to the next page, write down the question, and then we go through the process of checking the guess solution. Minus 4y prime plus 4y, and then I said this one should be 4 e to the power 2x. Right. So now we've gotten the complementary solution, which is equal to c1 e to the power 2x plus c2x e to the power 2x. Now general solution is yc plus yp. So for yp, we need to guess trial solution. So as I said, this is an exponential function. So we are going to guess this to be a times the exponential function here, which is e to the power 2x. But the question is now, well, let's go and compare this to the complementary solution. Now, when you compare this to the complementary solution here, you can see that I have this one here, which is also the same as this. And I have a constant, so I need to modify it because basically this is the same as this, since this is also the same as this. So I'm going to modify this by multiplying through by x. So I'll do that by multiplying this one by x. So this is now moved to ax e to the power 2x. Right? So we've moved from this to this because we are saying that this is basically the same as this. Now let's compare. As I said, when you write the second one to compare, now we can see that this and this are not the same because of the x. But let's look at the second term. The second term here is basically also the same as this. Can you see that? Because we have this here and then we have the x also here. So there is a possibility that C2 and A2 will be the same. So it means that we need to also change this because it's basically this. So we are going to multiply this one by x again. So this is going to move from x squared this. So we have moved from this to that. So we considered this one, it was not working because of this term. We considered this one too, it was not working because of this term. Now you can see that the new trial solution here is basically different from the whole of this because we have this one here, this one here, this one here, which is there, but this is x squared and we don't have any x squared here in the complementary solution. So that is basically what we just need to do so that we can guess our trial solution correct, because that is basically what we just need to do. As soon as we do that, the rest is differentiate, do substitution, compare, find your A, done. So now let's go through the process. We differentiate this. This is a product rule. So I maintain A. Now here I'm going to maintain x squared and differentiate this. So we know that when I differentiate this, I'm going to have 2e this, and when I differentiate x squared, I'm going to have 2x. So product rule, if this one is my A and this is my B, this is A prime, this is B prime. So this times this plus this times that. So that will be the product rule from there. So 2x e to the power 2x plus 2x squared e to the power 2x. So I just multiply this one by this, which is here, and this times this, which is also here. So that is the product rule. Good. Now that I'm done with the product rule, I need to also differentiate it again. So y prime prime is equal to A. Now again, this is a product rule. So I will choose A to be equal to 2x. When I differentiate A, I'm going to have 2. Now choose B. I'll choose B to be equal to e to the power 2x, and B prime will be equal to 2e to the power 2x. So I'm just working with this. So multiply this one by this. This is going to give us 4x e to the power 2x plus multiply this to this, which is going to give us plus 2e to the power 2x. Plus again, now this is another product rule again, but now I'm going to choose my A to be 2x squared, and A prime will be equal to 4x, and my B will be e to the power 2x, and my B prime will be equal to 2e to the power x, 2x. So this times this plus this times that. So we are going to have 4x e to the power 2x plus 4x squared e to the power 2x again. So this times this is going to give us this, and this times this is also going to give us that. So let's try and simplify them, and then we just plug them inside the function. So let's see that. Simplify this. So this is going to give us 2xa e to the power 2x plus 2x squared a e to the power 2x. And this is going to give us, now we can see that this term here is the same as this term. So we can add it and get 8. So we are going to have a 8x e to the power 2x plus 2 e to the power 2x plus 4x squared e to the power 2x. Multiply through by a, and we are going to have 2 8 plus 2a 2x plus 4a squared x squared a e to the power 2x. So now that I have y prime 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 and y, I'll plug it inside the solution here. So the only thing is, like, how to do the differentiating tool is also very important. So we have y prime prime, which is equal to this. So I'm going to have 8x a e to the power 2x plus 2a e to the power 2x plus 4x squared a e to the power 2x. Then minus 4y prime. So minus 4 minus 4. Y prime is here. So let's do that. 2x a e to the power 2x plus 2x squared e to the power a e to the power 2x. Then plus 4y. So we know that y is this. So plus 4y. Y is a x squared e to the power 2x. Is that right? Good. And this is equal to 4 e to the power 2x. Good. So now let's try and simplify and then compare. So still we have this plus 2a plus 4x squared a. So I just repeated everything here, the same thing here. Then I'll multiply the minus 2 through this. So I'm going to have minus 4, 8. So 2x minus 8 again, x squared a e to the power 2x plus, I'll repeat the whole of this one too again. 4a x squared e to the power 2a is equal to e to the power this. So let's see if we can cancel some terms. So I can see 8x a e to the power this one out here, and then I can see also this one. So this one will cancel out because this is positive and this is negative. Good. I can also see 4a squared to the power 2x, the same thing here. So when I add this and this, I'm going to get 8, and it's going to cancel this because this is minus. So this and this and this will be 0. So it's going to be left with this guy and this guy. So we are going to have 2a e to the power 2x, which is equal to this 2x. And compare the coefficients of this, and we are going to have 2a is equal to 4, and a is going to give us 2. So now we can put 2 for the a, and our particular solution will be 2, right? Good, we have 2 x squared e to the power 2x. So this will be the particular solution. So it means that our general solution, which is y is equal to the complementary plus this is going to be, what do we get for complementary? We had c1 e to the power 2x plus c2x e to the power 2x plus, and then particular solution you've gotten 2x squared e to the power 2x. Is that right? Good. So this is another way of getting the complementary solution and particular solution and getting your general solution. Let's look at the last question, and then I'll give you a trial question to do. So this one too, the way that we are going to guess the particular solution is different. So you see that all the 3 examples, we are getting different way of guessing the particular solution or different answers for the trial solution. So the same thing again, general solution, this should be equal to complementary solution, particular solution. So for complementary solution, we assume that the left side of the second order non-homogeneous equation is equal to 0. So we go through the same process again. So I'll write fast. So y prime will be equal to this. Y prime prime will be equal to m squared this. So what do you think? This one, when I do substitution, I'm going to have this plus minus 2 e to the power mx plus 5, and I'm going to have this, which is equal to 9, no, which is equal to 0. Good. So you know that this one, we need to factor this out. So m squared minus 2m plus 5 is equal to 0. Good. And then what do we need to do again? We assume that this guy is never 0. And then now we pick our polynomial, characteristics polynomial, which is m squared minus 2m plus 5. Now for roots, characteristics root, this and this should be equal to 0. Now I can see that this is basically going to give us a complex because this is bigger than this. And when I square this and multiply this one by 5, it's going to be negative. So I need to use my quadratic unless I cannot solve it. So A is 1, B is minus 2, and C is 5. So we know that quadratic formula is of the form minus b plus or minus square root of b squared minus 4ac divided by 2a. So this is the quadratic formula. So let's go. M will be equal to minus 2 plus or minus square root of minus 2 squared minus 4a times c divided by 2 times a. So let's go 4 plus or minus square root of 4 minus 20. So as I said, we can see that 4 minus 20 is going to give us something like square root of minus 16 divided by 2, and 4 plus or minus. So we know that square root of 16 is 4, and square root of minus 1 is I. So this is going to give us 4i divided by 2. Good. And this is going to give us 4 divided by 2 plus or minus 4 divided by 2i. And this is 2 plus or minus 2i. So this is going to give us the complementary solution. So here we can see that our m is equal to 2 plus or minus 2i, which is of the form u then I, right? So this is the form. So remember how to write the trial solution for the complementary solution when we have a complex, right? So this is going to give us c, which is equal to e to the power ux k1, and then we have the cos of ven x plus k2 sine of ven x of that. So as I said, the values here, you can change them. Somebody can use alpha, beta, somebody can use x, y, any of them is right. So basically this is what I'm using throughout the video, so that's why I'm keeping them. So now let's go. Our complementary solution will be 2x k1 cos of 2x plus k2 sine of 2x. Good. So that is what we are going to get for the complementary solution. So now that we've gotten the complementary solution, let's go and see how we can also figure out the trial solution. So the question given to us is y prime prime minus 2y prime plus 5y is equal to 9 e to the power x, and then our complementary solution is e to the power 2x k1 cos 2x plus k2 sine 2x. Now we know that general solution, complementary, particular solution. Let me check if my complementary solution is right, and this one too is right. Okay, now we need to guess. So for particular solution, we need to guess. So as I said, this is an exponential function, so the first guess is a times the function here, which is e to the power x. Right. So now what we need to do is we need to look at the term here and see if we have this term here inside this. This is not the same as this. So it means that we are going to have the same thing. We are going to use this. So always compare your first trial solution with this one and you start modifying it. So since this is not the same as this, we cannot do it. Somebody is asking, what if it's the same? If this one is the same as this, now when I multiply this one by this is what I'm going to get. I'm going to have something like this. So let me clarify that. I'm going to have something like k1 e to the power 2x cos 2x plus plus k2 e to the power 2x sine 2x. And you see that even though we have this one here and we have the constant here, we have cos which is not here. So they are not the same. Unless maybe this one too is going with cos, then we can say that this is the same as this. Yes. So even if this one is 2, since this one is not the same as that, we don't go through the same process again. So this is still the same thing as that. So y prime is going to give us the same thing, and then y prime prime is going to give us the same thing again, because when I differentiate e to the power x, I get the same thing. Let's do substitution and let's go. So let's plug them inside the original equation. So I'm going to have a ex minus 2 times a ex plus 5 times aex, which is equal to 9ax. So add this. This is 1, 6, and this will be 4. So 4aex is equal to 9ex. Compare ex, coefficient. So we are going to have 4a to be equal to 9, and a is going to give us 9 divided by 4. So it means that the particular solution yp will be equal to 9 divided by 4 e to the power x. So now we can write the general solution. So general solution, so I'm writing this one big because this is the last question on this. I'm going to give you a trial solution to try. So we are going to have y, which is equal to the complementary solution plus the particular solution. So y is equal to e to the power 2x in brackets k1 cos of 2x plus k2 sine of 2x close plus the particular solution, which is 9 divided by 4 e to the power x. Is that right? Good. So this will be the general solution. So you see that whenever we are talking about non-homogeneous, what we can notice is we can see that we can have any form of non-homogeneous. It can come with when we have the root to be complex. It can come with when we have the root to be repeated. It can come with when we have the root to be distinct and real, right? So we can have all the form. But the idea is that how we can also guess the particular solution and solve. So this first method is how to solve the non-homogeneous aspect whenever it is what? Exponential function. So we've gone through all the questions that you might be asked, different type of question that you might be asked whenever you have the non-homogeneous aspect to be an exponential function, how you are going to write your trial question or your trial solution. So try this, and leave your general solution in the comment section. I would like to see your complementary solution, your particular solution, and then your general solution. Or you can just write the general solution inside straight away, because as soon as you write the general solution, I will see the complementary solution and then the particular solution. So I've given you the same trial. Try all of them and leave your answer in the comment section. In the next video, we are going to talk about method 2 or case 2, where we have a polynomial function as the non-homogeneous part of the second order of non-homogeneous equation. So see you in the next video.